Hi everybody, welcome back. Today is Wednesday and we're starting a new topic called volume of rectangular prisms. So you're going to notice something different about this shape that I have on the screen. So far, think back to before spring break, the kind of shapes that we had been dealing with were, of course, that's a rectangle, a square, a triangle. We did trapezoids or even the circle. All of these shapes from before. These are all what we call 2D shapes. You see how they're just two-dimensional, they're flat on a piece of paper if you drew them, compared to this cube, which is a 3D shape, right? It kind of looks like it's popping out off the page. That's 3D, three-dimensional. And the previous shapes we've done, these are all two-dimensional. When it comes to three-dimensional shapes, we find something called volume. We don't solve for area. Area has to do with two-dimensional shapes. 3D shapes have volume, and this is the thing that we're going to be talking about today. Volume, if you can tell by this picture, this is kind of like a box, and there's something inside of it. Water, looks like, whatever it is. So volume is basically what can fit inside of an object, a box, a cube, whatever it may be. Volume is the total like space inside. Area was also space inside, right? If this was just a normal rectangle, a flat rectangle, area would be the space inside, but inside of a 2D. When it comes to this 3D cube box, we call it volume. So that is our goal for today. You're going to be able to calculate volume. Right, there's the objective, that you will be able to calculate volume by using the volume formula. So there will be a specific formula you learn today. That's going to be another one of those formulas that you don't necessarily have to memorize because it will be on the star chart, but you should know what it's for and how to find it, etc. Okay, some definitions to start us off. Volume is the total area. It is like area, remember I did say this before, but it is area of a three-dimensional object. It describes how much space an object occupies. Next, this says to shade the bases of the rectangular prisms below. Then describe how would you find the area of the bases. Okay, I'm going to shade the base. The base is most of the time, the obvious part is that it's just what it's sitting on, right? The bottom of the shape. Those are the bases shaded. Now let's find the area of these. Okay, what shape is that? That is a square. There's no numbers here, so we're just going to write the basic formula. The area of a square would be base times height, or length times width, if you want. This one is a rectangle. How do you find the area of a rectangle? It is base times height. Finally, that's also a square, so it's going to be area equals base times height. Okay, these are going to be small parts that we'll build on in a little bit, so that's something you should notice. Now, a couple of other features I want to point out about prisms, rectangular prisms. Notice that they have 6 sides, right? You have to count all the sides of the boxes, of the box, 1, 2, top and bottom, left and right, front and back, 6 sides total. Grab anything that's next to you that looks like a cube or a box and count the sides, and you'll see that for yourself. The 2 sides that are opposite each other, and they're the only 2 that are just like each other, those are the bases. Because, what if that shape, that first shape, was actually, well, let's see if I'm good at drawing this using a mouse. What if I took this shape and I laid it flat like this instead? Okay. Same thing, but rotate it around. What would I pick as the base this time? Would I pick what it's sitting on? Actually, I would not. I would still pick the two end points, the squares on either end, as the bases. And why is that? Because you pick the two sides that are the only two like each other, right? The other ones, all of the other sides, that one and the longer sides, there's four of them that are like each other. And so you don't pick those. Those are called the faces. Those are called different names, but the two that are like each other, those are the ones that we call the base. Okay. Something important that you'll see will come up later. We're just going to fill in a few of these blanks, but these are not super important right now. They're not something you have to memorize, is what I mean, but we'll fill them out. So the base of a three-dimensional shape, or sorry, the base of a three-dimensional object names the shape. A prism has two bases which are parallel to each other, meaning they do not touch. Okay, and speaking of rectangular prisms, volume can be determined by finding the area of the base and multiplying it by the height of the object. And so that brings us to our volume formula. Volume equals capital letter B, notice that, times H. It's super important that y'all notice that volume equals capital letter B times H. If you put lowercase b times H, that is the area formula for rectangle or square. So of course, I know what you're thinking. So what's the difference between capital B and lowercase b? This is very important that you get this. Lowercase b was just base, right? Base times height. Capital letter B stands for area of the base. And you'll see the difference between that in a second when we do some actual examples. For now, you need to know this is the volume formula. Volume equals big B, capital letter B, times H. There is one other formula for area that I will give you, sorry, for volume. I'll give you a better one actually, but I'll do it when we look at our actual examples. For now, just write that one down. Okay, here we go. So we have a rectangular prism. That is a rectangular prism. And we're going to show our steps in this chart. The formula, like I said, volume equals big B times H. And we plug in the values. But before we plug in the values, we have to kind of pick out, let's kind of look through this box. Try and see through. I'm doing a dotted line. Okay, and now you can look through. And we're going to highlight the base. That would be the base of the whole box or the prism. According to our volume formula, we need to find the area of the base, right? Volume equals capital letter B times H. Big B stands for area of the base. So what is the area of that yellow part that I shaded? The area would be base times height, which is 6 times 9 is 54, times the height of the whole shape, and that's where this 4.5 comes in. You would multiply that to get your final answer. So 54 times 4.5. 54 times 4.5 is 243. Okay, make sure you wrote that down and keep that in mind. Now I'm going to show you something else. In math, you know, there's more than one way to do it. There's always more than one way to kind of reach the same end goal or the same right answer, and you have to pick the easiest way, the most straightforward way, and I'm about to show you an easier formula than this. The other volume formula, for rectangular prisms can be written as length times width times height. It's the exact same thing as the other one, and you will get the exact same answer. In a way, so if we plug in numbers for this, right, if we're doing volume equals length times width times height, look at what happens actually. So we would put the length as 9, the width is 6, and it doesn't matter which one you pick as the length and the width. And the height of the shape, like how tall the whole shape is 4.5. And then you can see that our next step would be, well, 6 times 9 is 54, and the height is 4.5. Doesn't this kind of look familiar? Wasn't this basically how the previous formula was? So it's the same thing. That's my proof of showing you that it's the same thing. And you'd work it out and you'd still get 243. Same exact answer, but using a different formula that has different parts in it. Okay, you pick which formula you like and stick with that. I'm going to guarantee that probably 99% of you like this one. I do as well. I don't like the fact that there's a capital letter B, and I had previous formulas that had a lowercase b. It's just something that can throw you off. But I will tell you that on the star reference chart, the formula chart, they're going to have volume equals big B times h. So if you like length times width times height, you are responsible for remembering that by yourself. That goes with boxes, rectangular prisms. Okay, a couple of things we need to wrap up here on this slide. That is units. I got this answer of 243. It needs units, centimeters of course. Because this is a 3D shape, we need to put a small 3 cubed next to it. It's because it has 3 dimensions, you know, a length, a width, and a height, and that's why it's a 3. Remember when we were doing area, normal area, we would put, you know, whatever number we got, and we would put centimeters squared. That's because it had 2 dimensions, just a length and a width. This time we have 3. So the little 3 is only for volume. Alright, there's a lot of important stuff here. Rewatch this part of the video if you need to. Now let's jump in to do some practice. We have 12 examples here to find the area, find the volume. You pick whichever formula you want, and I would guess it would be length times width times height. Stick with that and be consistent. That way that formula that you're using kind of stays in your head. And we're going to practice finding the volume for all these different types of rectangular prisms. We're not going to do all, or I'm not going to work out every single one in the video. You will do all of them on your own. Let's pick out, we'll do number 1, number 2. I'm picking like different, everything that's a little different, one of each kind of. So we'll do number 1, 2, 5, and 12 in detail together on the video. And then you can work out the rest by yourself. 3, 4, 6, 7, 8, 9, 10, and 11. Okay, so number 1. Find the volume. Write your formula first, guys. Length times width times height. And then plug in numbers. Length 8.5. Does it really matter which I pick? No, because they're all getting multiplied and the order does not matter. But you know, we can see that the height, 6 is how tall it is, so naturally that's the height. And then you just multiply straight across. Doesn't matter in which order. 8.5 times 4 times 6 is 204. There's no units for this one. 204. Just remember your rules about decimal multiplication. Okay, I didn't actually show the step, but you would have to work it out by yourself. Number 3. Yeah, I thought I said we would do sorry, we're going to be doing a number 3, not number 2. Okay, number 3, find the volume of this cereal box. Whatever the case may be, this is still a rectangular prism, right? Boxes basically are rectangular prisms. Length times width times height. Plug in the numbers. Length of the box, 18. Width of the box, 3. Height of the box, 22. And multiply. 18 times 3 times 22 is 1,188. Again, no units on this one. What does volume mean? Again, we're getting this random number. What does it mean? It means that's how much you can fit inside of the box. It's all of the space on the inside. Okay, two more examples. How do we do number 5 that has no numbers on it? But they have cubes and we can come up with the numbers, right? We need to do volume equals length times width times height. Well, what's the length? How many squares make up the length? 1, 2, 3, 4, 5. What about the width? That's 2. And what about the height? That is 4 squares tall. So we have 5 times 2 times 4. 5 times 2 is 10. 10 times 4 is 40. Okay. And last one that I will do on the video at least. Number 12, volume equals, again, length times width times height. And plug in. This is a good one, a good example of one that has a fraction thrown in. You can just change that to 5.5. You might see fractions on some of your shapes. 5.5 times 2 times 10. 5.5 times 2 is 11, and 11 times 10 is 110. Okay, so this is basically volume. To summarize, volume of a shape is all of the space on the inside of the shape, and volume applies only for 3D shapes. And the other thing that you learned was that there is a given volume formula, and that is volume equals big B times H, but I gave you a better one, which is volume equals length times width times height. Use this one always for when you do rectangular prisms. And you had a handful of references, examples worked out. So what you should do to wrap up these notes is on your own work out all the ones that are left, 2, 4, 6, 7, 8, 9, and 11. That'll give you a little practice. Try those on your own, and you'll have a homework that goes with this as well. All right, hope you understood everything, hope it was clear, and good luck.